Now we are going to another result. That is, come to the theorem. If x equals secant xn be a contractive sequence, which is contractive, means we can find out, or we can find out a c lies in between 0 and 1 such that mod xn plus 2 minus xn plus 1 less than or equal c into mod xn plus 1 minus x. Then, and the limit x equals, means limit x means limit x, limit of sequence xn, limit x equals x star. Then the theorem states that modulus of x star minus xn, mod x star minus xn less than or equals c power n minus 1 by 1 minus c into mod x2 minus x1. This is the first result. And second result says that modulus of x star minus xn, which is less than or equals c by 1 minus c into modulus of xn minus xn minus 1. These are the two results, where xn is a contractive sequence. So the first part is immediate. Why? Because of our previous theorem. Previous theorem says that if x equals xn is a contractive sequence, then xn, sequence xn converges. Okay. Here we say that limit x equals x star. What is x? X equals xn. Limit x equals xn means the secant xn has a limit point, that is x star. That means secant xn is a convergent sequence. Therefore, x star, but as x star minus xn, which is less than or equals c power n minus 1 into 1 by 1 minus c into mod x2 minus x1, that is already proved. Why? Because of previous arguments. From there, we obtained modulus of xn minus xn less than or equals mod x2 and so on. Okay, c power n minus 1 into, by 1 minus c into mod x2 minus x1. This is already obtained result as by previous theorem. Okay. How to prove the second result? Modulus of x star minus xn less than or equals c by 1 minus c into mod xn minus xn minus 1. How to prove this one? We have, for m greater than n, modulus of xm minus xn, we know that contractive sequence is Cauchy. We see that contractive sequence is Cauchy. Mod xm minus xn, so which is less than or equals, as by previous argument, it is modulus of xm minus 1 plus mod xm minus 1 minus xm minus 2 plus etc. plus modulus of xn plus 1 minus x. Okay. But since what is xn? Xn is contractive sequence. It means modulus of it is modulus of xm plus or xn plus 1 minus xn. What is modulus of xn plus 1 minus xn? Since it is contractive, it is less than or equals c into modulus of xn minus xn minus 1. Why? Because xn is a contractive sequence. So the result is true for, this result is true for n equals 1. Or the result is true for SSR. Now we assume that the result is true for k equals p. Assume the result is true for some k equals p. That is modulus of xn plus p minus xn plus p minus 1. Okay, from here, suppose the result is true for n equals p or k equals p, whatever may be, n equals p. So it is modulus of xn plus p minus xn plus p minus 1, which is less than or equal c into modulus of xn minus, c power p into modulus of xn minus xn minus 1. Why? Because we assume that the result is true for k equals or n equals p. Okay. So it is modulus of xn plus p minus xn plus p minus 1 less than or equal c power p into mod xn minus xn minus 1. Now consider modulus of xn plus p plus 1 minus xn plus p. Modulus of xn plus p plus 1 minus xn plus p. So since it is a contractive sequence, It is less than or equal c into modulus of xn plus p minus xn plus p minus 1. So it is less than or equals, but this is less than or equals this one. So it is c power p c into c power p into modulus of xn minus 1. Why? Because of this argument. Means it is equals c power p plus 1 into mod xn minus 1. So it is modulus of xn plus p plus 1 minus xn plus p less than or equal c power p plus 1 into mod xn minus 1. That means this result is true for n equals or k equals p plus 1. So by induction hypothesis, you can say that modulus of xn plus k by induction hypothesis, it is modulus of xn plus k minus xn plus k minus 1, which is less than or equals, it is c power k into modulus of xn minus 1. Why? Because of the induction hypothesis. Okay. So for m greater than n, so it is modulus of xn from here. So modulus of, consider this argument. Modulus of xn plus k minus xn plus k minus 1 less than or equals c power k into mod xn minus 1. This is obtained result. Now you can apply this result here. What do you get? So it is modulus of xn plus p, that means modulus of xn minus xn less than or equals, what do you get? Mod xn minus 1. So here we know that mod xn minus 1 is nothing but it is c power m minus n into modulus of xn minus 1. Why? Because of this argument. Okay. C power m minus n into mod xn minus plus whatever this term, that is c power m minus n minus 1 into modulus of xn minus 1 plus etc. plus. What is the last term? It is c into modulus of xn plus 1, xn minus 1. Clear? So that means it is equals modulus of xn minus 1 into c plus c square plus etc. plus c power m minus n minus 1 plus c power m minus n in this direction. So that equals modulus of xn minus 1 into, take a c outside, so it is c into 1 plus c square plus etc. plus c power m minus n minus 1. Okay. So which equals, or which is less than or equals modulus of xn minus 1 into c into 1 plus c square plus etc. What is the term inside this bracket? That is nothing but a geometric series having common ratio c, but c lies in between 0 and 1. Therefore, the sum of this infinite series is modulus of xn minus 1 into c into, it is 1 by 1 minus c. Okay, that is, so it is finally modulus of xn minus less than or equals modulus of xn minus 1 into c into 1 by 1 minus c. So that means modulus of xn minus less than or equals c by 1 minus c into modulus of xn minus 1. So letting m goes to infinity, m goes to infinity means the secant xm, the limit point of secant xm, that is nothing but x star here. Why? Because limit x equals x star. Limit x means it goes to m goes to infinity. Okay, so it is that is modulus of x star minus xn less than or equal c by 1 minus c into modulus of xn minus 1. So this is the theorem. Okay, so these are the two important results.